Hello and welcome to video number 11 in this video series. And in this video I'm going to provide some examples of factoring polynomials. So in the last video we talked about multiplying two polynomials together to get another polynomial. So as a very simple example, we could multiply this polynomial 2x squared by this polynomial x minus 4, and we end up with a new polynomial 2x cubed minus 8x squared. The 2x squared and the x minus 4 are called factors of 2x cubed minus 8x squared. If we go from 2x cubed minus 8x squared back to the two factors that multiply together to create this polynomial, that process is called factoring this polynomial. And that turns out to be an important thing to do as you move on through your math journey. So the reason that it becomes important in certain areas of mathematics is often we're looking for where a polynomial is equal to 0. And by factoring the polynomial, we can easily see where this polynomial is equal to 0. So in this case, this polynomial is equal to 0 when either this factor is 0, so that would happen when x is 0, or when this factor is 0, and that would happen when x is 4. So as another example, let's do 3x cubed minus 3x squared plus 6x. And let's try and factor that polynomial. So what we're looking for is a factor for each of the terms. So a common factor for each of those terms, so that we can pull out that factor and kind of separate it. So what I can notice here is that in terms of the constant that's multiplying, the constant coefficient that's multiplying each of these powers of x, we've got 3. So 3 is a common factor, but also we've got x cubed, x squared, and x. X is going to be a common factor. So 3x is a common factor. And then I just have to figure out what I multiply 3x by to get this polynomial. So to get the first term, I'm going to have to multiply 3x by x squared. To get the second terms, I'm going to have to multiply by minus x. And for the third term, I need to multiply by 2. So I factored this polynomial 3x cubed minus 3x squared plus 6x into two factors, 3x and x squared minus x plus 2. Degree 2 polynomials are called quadratics. And I'll spend a little bit of time just going through factoring quadratics, because that's a very common task that you'll need to perform. So as an example, let's think about this quadratic. Let's do another color. Let's do x squared plus 5x plus 6. And I want to factor that. So the form of the two factors is going to be x plus some number, a, and then x plus some other number, b. And I just need to figure out what a and b are. So if we look at the form of this quadratic, I've got just the coefficient for x squared is just 1, so that's going to work out here because I've got x times x, so that's okay. If I look at the constant term, that's going to come from multiplying a and b. So a and b are going to have to multiply to get 6. And then as far as the x term, if I think about the two factors here, I'm going to have a times x and also b times x. So the sum of a plus b is going to have to equal 5. So I need to think of two numbers that multiply together to get 6 and add to get 5. So it's fairly easy to see that two numbers that work there are 2 and 3. And if we multiply this out, we're going to get this polynomial, this quadratic polynomial. Let's do another example. Let's do x squared plus 3x minus 10. And again, we're trying to find two numbers that, in this case, are going to multiply to give us minus 10 and add to give us plus 3. So if I think about the factors of 10, I've got 1 and 10, I've got 2 and 5, but I'm also thinking about here, I've got to get them to add together to get 3. So I think 2 and 5 ought to work, because one of them's going to have to be negative. And so if I'm going to end up with plus 3 here, I'm going to need plus 5 and minus 2, because 5 times minus 2 is minus 10, and then 5 minus 2 is 3. So this is kind of an important kind of skill to develop, the ability to go from a quadratic into its factors. And part of the motivation for that is we're often looking for where the polynomial is 0, and we can easily see, for example, in this case, this polynomial would be 0 when x is equal to minus 5 or x is equal to plus 2. In the last video, we did an example where we multiplied 4x plus 3 and 4x minus 3. And I said this was the conjugate of this. 4x minus 3 is the conjugate of 4x plus 3. And what was interesting about multiplying these two polynomials is that we get the term, the partial product from multiplying 4x and 4x. And then we get the partial product from multiplying plus 3 and minus 3. But the other two partial products cancel each other out, because we've got plus 12x from multiplying these two and minus 12x from multiplying these two. So whenever we see a polynomial that kind of looks like this, so there's a term here which is a perfect square, and another term here which is also a perfect square, then we can factor it using the idea of conjugates. So for example, if I want to find the factors for 9x squared minus 4, I've got a perfect square here, which will be 3x, because if I take 3x and I square it, I get 9x squared. I've got a perfect square here, because 2 squared is 4. So I know that I can factor this as 3x minus 2 and 3x plus 2. I wrote it round with the minus here and the plus here. It really doesn't matter which order you write the factors in. But just checking, we did the right thing. 3x times 3x is 9x squared, and minus 2 times plus 2 is minus 4. And then the other two partial products cancel out, because we've got minus 6x and plus 6x. Let's do another example. Let's do 4x squared minus 25. So that's going to be 2x minus 5, 2x plus 5. Because the 2x's combined to make 4x squared, and the 5's combined to make 25. Let's do another related example. Let's do x squared minus 5. Okay, in this case, this is a perfect square. But 5 is not a perfect square. There's no whole number that we can multiply together to get 5. But if we expand our number system that we're working with into all real numbers, so not just rational numbers but irrational numbers as well, then we could factor this, again using the idea of conjugates, as x minus the square root of 5 and x plus the square root of 5. And just checking that we did the right thing, we're going to have x times x gives us the x squared, and then we've got minus root 5 times plus root 5. Multiply those together and we'll get minus 5. And then got minus root 5 times x, which will cancel with plus root 5 times x. And then the other thing we can think about is, here we've just got one variable, x, but we could also think about factoring when we've got more than one variable. So as an example, let's do 6x cubed y minus 15x y squared. Let's try and factor that. So when we're factoring, we're looking for a common factor for each term. In terms of the coefficient in front, the 6 and the 15, a common factor there would be 3. And in terms of the x cubed y and xy squared, a common factor would be xy. So 3xy is my common factor. And then what do I need to multiply? 3xy by, to get 6x cubed y, I'll need to multiply by 2x squared. And then what do I need to multiply 3xy by to get minus 15xy squared? I'd need minus 5 and then y. So let's work through a few more examples. Let's have 2x, x minus 4, and 3, x minus 4. Now remember, we're trying to find common factors for each of these terms, and we can see right away that x minus 4 is a common factor. So I'm actually going to write the common factor with a space, because I can see that 2x I can pull out of the first term, and then 3 I can pull out of the second term. Second example, let's do 2x cubed x minus 3 and 2x x minus 3 squared. So looking for common factors, 2x x minus 3. And then I need to multiply by x squared for the first term and by x minus 3 for the second term. And that's as far as I go. I can't factor this any further. A third example, let's do 2x cubed minus 2x squared minus 24x. So a common factor here would be 2x. And then we'll have x squared minus x minus 12. And then I can actually go one more step with this one, because I can factor this, because I need two numbers that multiply to give me minus 12. So plus 3 minus 4 would do that. And when I add them, I need to get minus 1. So 2x, x minus 4, x plus 3. And just check. Anytime you factor a quadratic, always check that you've done it correctly. So for the constant term, I've got minus 4 times plus 3, which should be minus 12. And then for the x term, I've got minus 4x plus 3x, which does give me minus x. And then fourth example, let's do 3x cubed y minus 12x y cubed. So common factor here would be 3x y. And then the first term, I need another x squared. And then the second term, I need 4y squared. And I can also go one more step here because I can recognize that this is in the form of a perfect square minus another perfect square. So I can factor this using conjugates. So it would be x minus 2y and x plus 2y. And again, every time you factor this kind of polynomial using conjugates, just double check by going backwards to make sure that you did it correctly. So I've got x squared, and then I've got minus 2y times plus 2y, so that'd be minus 4y squared. And then minus 2xy plus 2xy would cancel out. So at this point, pause the video and work on the next two problems that I'll give you and see if you can come up with the answers yourself, and then start the video again and review if you got them correct or not. So for the first problem, let's do 3x squared plus 9x and minus 12. So see if you can factor this. And for the second one, let's do x cubed plus 2x squared minus 9x minus 18. And I'm going to give you a hint for this second one because sometimes it can be a little bit difficult to get going with these problems. So I'll give you a little hint with this one. If we regroup this and write it in this form, so combine the x cubed with the minus 9x, and then the plus 2x squared minus 18, then that should get you going with this one. So for this first one, first thing we can do is pull out a common factor of 3. So we'll have 3x squared plus 3x minus 4. And then we can see if we can factor this quadratic if we can find a number, two numbers that multiply together to give me minus 4 and that add to give me plus 3. So I think, let's see, plus 4 minus 1 would work because they would multiply to give me minus 4 and add to give me 3. So I'm going to have 3 and then x will have plus 4 and x minus 1. And just double check, we'll go backwards, make sure we get what we started with. We'll have x squared, and then we'll have 4x minus x, so we'll have plus 3x, and we got 4 minus 1 times minus 1 minus 4. And then multiply everything by 3 and we'll be back where we started. So I think this is correct. And then with this one, so I gave you the hint of rearranging this into x cubed minus 9x, and the reason I wanted to do that was because I'm going to pull out a common factor of x here and be left with x squared minus 9, and I'm going to pull out a factor of 2 here, and then I'll have x squared minus 9. And then now I've got a common factor of x squared minus 9. So I'm going to have x plus 2 times x squared minus 9. And then I can recognize that this is in the form of a perfect square minus another perfect square. So I can factor this using conjugates. So I'll have x plus 2, and then x minus 3, x plus 3. And again, we'll just check we did the right thing by kind of going backwards. So x minus 3 times x plus 3 would give me x squared minus 9. So that's this piece. And then the x plus 2. And then I can separate this into an x times x squared minus 9 and a 2 times x squared minus 9, which is this step. And then that gets me back to where I started. So that's all for this video. And in the next video, I'll finish off working with polynomials by looking at what happens when you divide one polynomial by another polynomial, and that leads to a new kind of expression called a rational expression.